Today we're going to do a quick review of domain and range. So just as a reminder, domain is all your possible inputs. So those are your X values. And range, you're going to be looking at your possible Y values. Mostly today we're just going to focus on graphical analysis of domain and range, and we're going to use the website Desmos. So if you guys are able to get to desmos.com, it's a very easy, user-friendly website for graphing, and it'll definitely help you a number of times throughout Algebra 2. So first we're going to start by looking at a data set. So I'm going to go over here and insert table. And then I have my X and my Y chart. So I'm just going to put in some random points. Okay, so once you have the table inserted, you can hide the list so we can look at the graph a little bit better. Now, as you can see, this is not a continuous curve, so the domain will look a little bit different than when it's a continuous graph. So when your data set is just a set of points, you're going to use the notation like this, off to the left. So we're going to say our domain, and what are our possible X values? Well, as you can see, there are only 4 possible X values for this function. So one of them is -3. The other one is 1. Then this has an input of 2 and an input of 4. Now those are the only 4 X values that are possible inputs for this function. There is no point over at 10 or -10 or -5, only -3, 1, 2, and 4. As for the range, we're going to look at the y-axis. So what are my possible outputs of the function? So for this data point, it has a y-coordinate of 6. This has a y-coordinate of 3. This has 6 again, so we really don't need to write it again because we already wrote it once. And then this has a y-coordinate of 9. Now typically I'd want to see the range written from least to greatest, so I would just expect you to rewrite it or do this the first time in order. So that's a really basic domain and range problem where it's just a set of points, but let's look at something a little more complicated. So we're going to go back into our editor, and I want to delete the table that we just had, and let's take a look at a linear equation. So you don't need to put y equals, so let's just look at x plus 3. So you guys have done this in Algebra 1, but as a review, this is a continuous graph. I can zoom out as far as I want to, and the graph will just keep going and going and going. There's no restrictions. So what this shows me is that this graph, y equals x plus 3, has a domain of all real numbers, because you can plug in any value in for x and get an output of y that is a real number. And the same goes for the range. Your range is also all real numbers, because for any x value that gets plugged into it, you're going to get an output that is a real number. So linear equations are pretty easy because the domain and range is always all real numbers as long as there are no restrictions. So let's take a look at something a little bit harder. We're going to go in and throw in a quadratic. So let's make this x squared instead of just x plus 3. So now we're looking at the equation y equals x squared plus 3. So when you're considering the domain, you can plug anything in here. You can plug in negatives, positives, zeros, any number, any real number can be squared. So the domain for this situation is all real numbers. You can also see this on the graph as we zoom out. On the x-axis, there is always a y value. Now it would just keep going and going and going and going. Further I zoom out, even over here at 500, if we had zoomed out far enough, you would be able to find that y value. So for this quadratic, your domain is all real numbers. Now your range isn't as easy because you can see on the graph there's a certain set of value outputs that the graph will never touch. This is because of the squaring. That always makes your values positive, and then we're adding 3. So even if we put in a negative number, let's say we put in, let's zoom in and say we want an x value of -5. So if we say -5, off to the side, -5 squared plus 3. -5 squared is 25 plus 3 is 28, which is still a positive output. Be careful with your calculator. It will lie to you here if you don't put the parentheses in and say that it's -25 plus 3. You guys know that that's actually a positive 25. So as you can see, even if we plug in a negative input, we're still going to get a positive output. So the lowest possible y value here is 3. And it can equal 3. So we're going to use the brackets that we discussed in class. So from 3 to infinity is your possible range. Let's take a look at one more. Now, if you had a graph that had some limitations on it, so let's say we had the curve. Now this is a piecewise function. We've seen this a little bit in Algebra 1, and we'll spend some more time on it later in the year. So right now I'm graphing the equation -2x plus 3 when x is between -4 and 4, and then I'm going to graph the equation -x, or x minus 8, sorry, from 4 to 8. So as you can see, let's make this plus 4. There we go, now they meet. So let's change the colors here. If you go to setting, we can go and change these both to the same color. So now we have this continuous curve. The domain and range is a little trickier on this one. So for this function that we're looking at, our domain, you want to say, well, what is my lowest possible x value? It stops right here. And on a graph, on a test or quiz, it'll be very clear. Is it filled in or is it open? Right now, since I put in less than 4, that would mean that that is an open circle because we can't actually equal -4. So it will be a parenthesis because -4 is our lowest possible x value, but it can't actually hit -4. So it goes all the way up there. And then it's going to continue. We have x values. We follow the x-axis. We have x values until we get to 8. And again, if you look at how I put the equation in, I don't have x is greater than or equal to 8. So that's why our end symbol is a parenthesis rather than a bracket. So let's go back to the graph and take a look at our range. So for your range, when you're looking at it graphically, we want to go from our lowest possible y value to our highest possible y value. So our lowest possible y value here, now these are both open circles, so this would be -4 to 12 is our range. Now we'll get more into open circle and closed circle later, but just need to know, can the value actually hit that point? If it can, it is a bracket. If it cannot, it will be a parenthesis. All right, so that should clear up some of your questions on domain and range. If you have any further questions, feel free to stop by and ask questions. Thanks.